Hey, welcome to Miss Miller's class math show. Today we're going to be going up, right-ish kind of diagonal lines, and you know that as slope. And here is Miss Miller with your slopes.
Don't forget Crystal.
Okay. You guys want to dance again? Can I turn it around? Woo! No? Some of us want to. No, we don't want to dance. Oops. Oops, wrong. Hey, it is one of those days. Here, all right, here we go. Ready? I'm going to turn around. I won't turn around to everybody. Everybody, here you are. No. Okay. Here we are, you guys. Let's have a round of applause for the fact that it is Friday and we all get to go home this weekend. Yay. Hey, we are talking about slope today. Slope is super easy. Slope is dope.
Oh, God.
Great. I know. I knew I was going to get a reaction like that. Well, it's one of my favorite things is getting people's reactions. Did you, at our audience at home, if you did not hear that, the reaction to my super cheesy comment was, oh, no. No. Okay, here we go. All right. What is slope? You guys tell me. We've done this before. This should be a review. Okay.
It's an M.
Everybody stop talking. Thane.
Slope is the rate at which things progress down or up.
Okay. A rate at which things progress down or up. I'm going to have Crystal go ahead and mark those. Thank you. Okay. Does anyone have another definition they could assign to slope? Yes, Brandon. A diagonal line. Good. Anything else? Rebecca?
It's a fraction number that tells you how many times you should go up.
Okay. Good. A fraction number that tells you how many times you should go up and over or down and over. Good. Lorenzo, did you have your hand up? No? Okay. What if I write this on the whiteboard or a piece of paper that's up here? Rise over run. Does that spark? Okay. Ooh. Okay. So, the letter that represents slope is M. Okay? M equals y2 minus y1 over x2 minus x1. That is if we are given, I just heard a grunt in the audience. Oh, here we go. X1, y1, make sure you all can see. X1, y1, and x2, y2. So basically, if we are given 2 points, we can calculate the slope using that relationship. So m equals y2 minus y1 over x2 minus x1. All right, so here we go. We are going to go through and look at what types of slopes exist. So we're going to start with a positive slope. It's always good to be positive first, right?
Yes.
Yes. That's what. Did I hear that right? Yeah. Okay, here we go. Shh. Cole, leave her desk alone. Thank you. Yeah, I'm calling you out on camera. Okay. Okay, still don't move her desk. All right, a positive slope. So clap if you would agree that when we read a book or read a web page or read a magazine, we read from left to right. Clap if you agree. That's good. Okay. So we also, when we're looking at a graph, we're going to look at the lines from left to right. A positive slope, I want you all to envision a person walking along this line on the top of the line. If they tried to walk on the bottom of the line, gravity would cause them to die, probably. They would be walking uphill, okay? So that's a positive slope. M is a positive number. Okay. So if a positive slope means we're walking uphill, what do we think a negative slope is?
Downhill.
That's good. Walking downhill. So positive slopes can be fun if you enjoy things like hiking. Or I'm getting laughs from the audience. They're like, who would enjoy that? I like hiking. Hiking is fun. Negative slopes. So a negative slope can be Really fun and exciting for what kinds of activities? What do you guys think?
Riding a bike.
Riding a bike, good. Skateboarding, good. Anything else? What is it? Sledding. Oh, yes.
Skiing.
Skiing.
I've never done skiing, but I want to.
Sliding. Snowboarding, good. My sisters and I, we used to go vacation a lot in Lake Tahoe when we were growing up. And my younger sister and I, we would love to, I don't know what, we had this one bike with like a really long seat on it. So we would both get on the bike, and like they had these really steep driveways. So we would ride down these steep driveways, and we were weird kids. There was like a really, like an old eaten corn cob laying on the ground at the end of one of the driveways. So we were like, let's run over it and see what happens. So we both got on the bike together. We ran over this old corn cob, and totally tumbled down the side of a mountain afterwards. Like we catapulted off. It was fun. My sister cried. She got hurt. I didn't.
Because you probably fell on my scale.
I fell on top of her. It was fun. Negative slopes can be fun. All right. Negative slopes can also be scary. How many people clap if you like to snowboard or ski or skateboard or do anything that involves going downhill in some way? Okay, so clap if you do that. So people are raising their hands. So you like downhill, yeah. It's fun, but it can be dangerous. Okay, the next two. These are the two that people get really tripped out on. But I'm going to give you a really graphic way to remember the difference between the two. We're going to do zero slope first. And then we're going to talk about an undefined slope. There's a really big difference between the two. And again, I will show you, whoops, ED. I hope that this visual will help you remember which one is which. So everybody draw a couple of graphs here. Oops, X, Y. All right. So let's start with zero slope. So a zero slope is a slope of 0. Okay. An undefined slope is M is undefined, or an undefined slope, or something like that. Okay, so you actually, like, it will not work. Okay, so if a positive slope is walking uphill and a negative slope is walking downhill, Tyler, what do you think?
Okay, I think it's just like flat.
That's flat. Good. Clap if you agree with Tyler that a zero slope is just flat. I agree. So this room, I think, I don't know for sure, I have not laid a marble down to see if it rolls around anywhere, but I would assume that we have a flat slope, the floor of this. Okay, now let's talk about undefined. If we're talking about people walking up, down, flat, what do we think undefined looks like? What do you think? Show me with your arms what you think it looks like. Okay, so I have, oh, this is interesting. I've got some people doing this, some people doing this, some people doing this. That's good. Okay. Again, if we're talking in the context of people walking up things, we're talking about a vertical line. If I wanted to just turn around and walk up this wall and kick the papers at the same time, would I be able to do that? Would I? Here's what would happen if I tried to walk up a wall like this. Let me put myself here, and I walk upwards. What's going to happen is I'm going to tumble down, and I'm probably going to hit my head, and I might even have this happen.
Okay.
Okay, so you all get my point, right?
No.
Okay, undefined slope. So let's just go back really quick. Let's look at each of these and just kind of make a mental note of what kind of equations we would be looking at for each of these. Let's start with the horizontal slope. That is a slope that's cutting through the y-axis. Does anybody remember an equation that would fit for a zero slope? I have a purple pinky, and it weirds me out every time I look at it. I donated, oh, you do, that's good. How many people donated for polio vaccines? Yay. You still can do that, you guys. If you want, it's like 25 cents buys one polio vaccine. It's really affordable. So, and then you can have a purple pinky, like Crystal and Rebecca and Alyssa and all of us who have purple pinkies. Okay, that's my plug for the day. All right, here we go. So, a slope of 0. What do we think about that? What if we think back, we go up on the if we think back, we go up on the y-axis and cut through. Alyssa? Good, perfect. Y equals 3. That would be a good example. Can anybody think of another one? It's y equals a number. Any number gives us a slope of 0. So what do you think, Alyssa?
Y equals 200.
Good. Can you think of any others?
8.
Y equals 8. Good. Okay. How about, so that would be for a slope of 0. Let's move this over. How about an undefined slope? Can we think of an equation that might work for that? If you're going over a certain number of units on the x-axis and cutting through it. Thane?
It can equal 2.
What could equal 2?
I forgot.
If you're going over on the x-axis,
Oh.
what do you think?
I forgot what I was saying.
Okay. Alyssa?
X equals negative 50.
Good. X equals negative. So x equals a number by itself gives us an undefined slope. Okay, now for the ones up here, the positive and negative slopes, both of these have both x and y in the equation. So y equals 3x plus 5. Y equals negative 2x plus 1. They have y and x both, okay? So let's go through and do some example problems. All right. Ready? Find the slope, if it exists. Sometimes it won't. And it won't if, again, you're trying to walk up walls and break your head open. Okay, 5, 0, and 6, 8. We're going to just start with a couple of points here. 5, 0, and 6, 8. I'm going to put one up here, and then I'm going to ask for a volunteer to do the second one. Okay? So, we put our formula up before. I'm just going to revisit that really briefly. So right up here we've got slope is y2 minus y1 over x2 minus x1. So we're going to go through and label our points first. The first point listed is 5, 0, so that's going to be x1, y1. The second point listed is 6, 8, so that's x2, y2. So if we know that the slope is y2 minus y1 over x2 minus x1, can somebody tell me how I can apply that to these specific coordinates, 5, 0, and 6, 8? Okay, everybody look up here. If I labeled x1 as 5, and y1 is 0, and x2 is 6, and y2 is 8, what do you think, Alyssa?
8 minus 0
Good.
over 6 minus 5.
Make some noise for Alyssa. They need a boost. Do you guys want to get up and do some laps or something?
No.
You all look really tired. I know what it is. It's too hot in
just
here.
ran over to
It is
the...
no, it is cold.
We ran outside of our classrooms a lot, so.
Yeah.
Yeah.
Oh, that's right. The space shuttle just flew over and everybody ran outside to see it. So now everybody is so tired. Okay, everybody ready? I want you to try and blow out the speakers, okay? Yell as loud as you possibly can. I'm serious. I want you to try and blow out the speakers, okay? I'm going to ask you what 8 minus 0 is and what 6 minus 5 is. Ready? What is 8 minus 0? Okay. What is 6 minus 5? Okay. What's 8 divided by 1? 8. Okay, good. So the slope is 8. See? Not difficult. Shouldn't be too difficult. If you're making it more difficult than that, you're making it way too difficult. Okay, who would like to do this one? The next one is a slope for the points 4, -3, and 6, -4. Sloan, you want to come up and do it? Cool. Okay, everybody give it up for Sloan. Keep giving it up for Sloan. All right. Oops. Okay.
Yeah. Here we go. Yeah. Here we go. I'm thinking about that. That's my favorite class. It's a pain in
singing along with it. That is awesome. Okay, so somebody tell me how she ended up with -1 on the top. Because if I look at that, I'm thinking that might have to be -7. So what's up? -4 minus -3. Shouldn't that be -7?
No.
No, Thane, why not?
Because a negative minus a negative would equal.
Good.
Like adding.
Perfect, perfect. And when she did that up here, but when she changed it to a plus, it got crossed out. Okay, good. Questions? All right, cool. Let's do something else. Sort of. Sort of. Okay, x equals 7. We want to find the slope of the line x equals 7. Now, I do not want you all to graph these. Let's have a round of applause for that. We don't want to graph this. But I want you, that's not entirely true. I just don't want you to write it down. I want you to graph it in your head. If we were to graph the line x equals 7, can someone walk me through the steps that we would take to do that? Cole? Good. He said you would go over 7 to the right and draw a vertical line. Give it up for Cole. Very good job, Cole. All right. Remember that lovely graphic visual of the person who tried to walk up the wall? That was me. And the head breaking open. What is the slope of x equals 7? Undefined. Good. Because a vertical line, you can't have somebody walking up a wall. Not yet. Give it 20 years and maybe we'll be able to. Okay, how about y equals 3? Y equals 3. Again, what I want you all to do is be visualizing in your head, not on paper, how you would graph y equals 3. So can someone walk me through the steps to graph y equals 3? Tyler?
You go up 3 on the y-axis and then you draw the
Perfect. So he said,
vertical, horizontal.
good. He said go up to +3 on the y-axis and draw a horizontal line. Give it up for Tyler. All right. So that is a flat ground. That is a slope of what? 0. Good. Okay. Now just to revisit this, if you the only way you can get an undefined slope is if you have 0 on the bottom of a fraction. Okay. 0 on the bottom of a fraction is undefined. If you get 0 on the top of a fraction, then you have a slope of 0. Okay, make a note of that. All right. Oh, I forgot about these last two. Okay, 5x minus 6 equals 15. So what's going to happen is you guys are going to get to this in your homework and have questions. So if we address the question now, we're good. Okay, so what do I do here? Anyone have any guesses? What I would do here? Thane?
Add 6 to the other side.
Good. We're still doing the same thing, finding the slope. So 5x equals 21, and then the last step would be what? Thane, just go ahead and do the last step.
Divide 21 by 5.
Good. So we get x equals 21 over 5. X equals a number by itself. That's the same thing as x equals a number by itself up here. What kind of a slope is that? It's undefined again. All right, how are we doing on questions? Why is it undefined? Who can explain why it's undefined? Shuggy? Exactly. So she said it's x equals just a number. So you would go over to that number on the x-axis and draw a vertical line through it. Give it up for Shuggy. Cole, what's up? Yep. Neither. I was just giving you an example of neither. So I was just saying that if you have 0 on the bottom of a fraction, it's undefined. But if you have 0 on the top, it's 0. Other questions? Last problem. Let's hear it for the fact that it is the last problem. That is the most enthusiastic that I have heard Sloan today. Nicely done, Sloan. Okay, ready? So find the equation. So the equation of the line containing the given point and slope. Point and slope. This chapter, I'm actually curious to get everybody's reactions. So this is a really long chapter. Is that a good thing or a bad thing to you all?
Love it.
So in other words, we don't have another test until either next week or the following week. Is that a good thing or a bad thing?
Good. We have plenty of time to study.
Plenty of time to study. All right. and more material to learn. Yeah, when they're long like this, it can be a little much on the teacher. Okay, one thing that I forgot to put in our key terms is point-slope form of an equation of a line. Point-slope form is just another way you can write a line. So I'm going to give you the general definition here. It is y minus y1 equals m times x minus x1. Write it down. It's not difficult, I promise.
Really not.
That's good. So Crystal says it's really not. Okay, so what we have here, this is what's going to make this so easy. We have 1 point listed. The 1 point listed is x1, y1. And we have an m. Okay, so can anybody guess what we're going to do with the x1, y1, and m that we have? Plug it in. Plug it in where? Good. So, Rebecca, where does start me out here? What do I plug in for y1? Why do you know 2? Good. Okay, how about x1? What am I plugging in for x1? Everybody, yell it out. What am I plugging in for x1? 3, and that's x1 over there. So 2, x minus 3. What am I plugging in for m? 4. Good. Okay, so now all I want to do is get y by itself. Can somebody walk me through how I would do that? Shuggy. Good. Distributive property first. When I distribute that, I get what? Good. Okay, and then last step? Perfect. Add 2 to both sides, so y equals 4x minus 10. And that is the end of the story. So if you can plug numbers in and simplify, good to go. How are we doing on questions?
Excellent.
All right. Everybody send us off. Friday, right? Send us off Friday.